from the UK, we have Arthur Vickers. He's our engineering manager for .NET Data. I'm Jeremy Lickness. I'm a program manager for .NET Data. And I can't tell you how excited I am to be on campus to tell you what's new with EF Core 6 with some help from my friend across the big pond there. So for those of you not familiar with Entity Framework Core, I want to give a high-level overview because perhaps you know someone who speaks in code. That's this robot here. And it seems like every developer at some point wants to write their own blogging engine, right? So this is some blog code, some classes defined. But we also have data in our applications. And our data master is probably going to speak a different dialect, maybe T-SQL, and describe the database this way. What Entity Framework Core does is it comes into the middle of everything, and it provides a feature called a DB context. And this is really the glue between your domain model and your database. And it allows you to fluently configure how those mappings work. So this enables you to take advantage of many benefits. These are things like writing strongly typed queries using language integrated query or LINQ. It allows you to work with your natural domain objects instead of weird property bags or tables or things like that. It allows you to use a single command. So what you can do is load a bunch of different related objects, manipulate them, delete them, modify them, and with one command, save them to the database. It'll translate that for you. We can fluently configure those relationships. We can handle optimistic concurrency out of the box, so multiple concurrent users is taken care of. And we provide that API consistently across whatever backend, whether it's PostgreSQL, SQL Server, Cosmos DB, all of these are handled and supported. And of course, we recognize that database schemas do change, so we provide a feature called migrations that handles those schema changes. Now, what I want to talk about now is what's new, because we packed a lot of functionality. The team was hard at work for EF Core 6. These are just a few of the items. I'll have a link at the end of this presentation that'll take you to more detail about what it is. Now, in the short time we have, we're only going to be able to demo a few of these features. I highlighted them there. But before we jump into that, I do want to talk about one feature in particular, and that's performance. So I'm excited to share that full stack, all up EF Core performance from EF Core 5 running on the .NET 5 stack to EF Core 6 running on .NET 6 has improved 92%. Now that's with the runtime improvements and improvements to EF Core. Massive improvement. And if anyone's using Dapper, we love Dapper. It's an open source product that serves a similar need. But if you're just going to it for performance reasons, you might want to revisit EF Core because we're within 2% on certain benchmarks of that query capability. Now, the other thing I wanted to point out was compiled models. And this is something that comes up when you have a really large model, a lot of objects and relationships, and you're starting up. EF Core goes out and looks at that model and figures out how everything is glued together. We've provided the ability to do this statically at development time. So with a very simple command, you can introspect your model and you can generate code that will basically speed up your startup time. So if you have a load balanced application, if you're running multiple instances, or if you're, for example, using Azure Functions and need fast startup, this addresses that need. But that's enough slides, enough talk. We've got so many features to show you. I'm going to pass it over to Arthur to show you some of these new features. Arthur, take it over.
Thanks, Jeremy. So building on what Jeremy said in his introduction, I have a really simple model here. I've got an order class, which is related to a product and a customer. We've got parameterized constructors here, private setters, init-only properties. EF Core is good at mapping to all different kind of structures you might have in your entities. We have a customer, again, using a parameterized constructor. In this case, we're using a non-nullable string property, and that'll automatically create a required property in the database. EF Core 6 is fully annotated for nullable reference types, and we use them internally as well. And then finally, we have a product here. And another thing that we've added in EF Core 6 are more mapping attributes. So for example, we have a precision attribute where I can say, okay, when you map this to the database, make the precision of this decimal property 18.2. So rather than having to do that in the Fluent API, you can just stick a precision attribute on it there. And then tying it all together, as Jeremy said, we have a DB context. And this is all the configuration that you really need for this. Just 3 DB sets, one for each of our tables, customer, product, and order. And then I'm using SQL Server local DB. And I'm also using implicit usings here. And in my CS project, I've added Microsoft Entity Framework Core here. So when you're in the DB context, there's no additional usings necessary there. It keeps it really nice and clean. Okay, so there's a couple of ways that you can use EF Core with databases. You can reverse engineer from an existing database, or you can use what we call EF Core migrations to actually create and manage the database for you. And I'm going to use migrations here to create this database. Now I have the .NET EF tool installed as a local tool in my project. There it is. And to create a migration, I just need to use .NET EF migrations add, and I just call it 1 for my first migration. And that's going to create a migration, builds things just to make sure everything is up to date. Once it's builded, I will switch back to Visual Studio. You can see we have a migrations folder, and in here we have the migration that's going to create the tables. Now, notice here that the string column is nullable false. It's a required string column because that was a non-nullable reference type. And the decimal is 18.2 as we configured it. I'm also noticing that our strings are all by default configured for any length of string, but sometimes you want to limit that. So instead of using nvarchar max, let's say we want to use nvarchar 200. So let me go back to my DB context. Now, the traditional way to do this, let me just grab some code here. The traditional way to do this is either to put attributes on each of the properties. You have to do it for every property, or alternatively to override on model creating like this. So people who've used EF will be pretty familiar with this. So this says for the name property, make it 200. For the name property on product, make it 200. And you do this for every property. Well, we have a new feature in EF Core 6 where there's another property, a different method rather, that you can overload on your DB context, and it's called configure conventions. And so for this, what we're saying here is for all properties in the model of type string, make the default max length here 200. So now basically we can get rid of all of this code, and in one line we can say make the default 200 everywhere. You can always override it with attributes or additional Fluent API specific properties, but this lets you do common configuration, including things like sending a value converter. So I've made that change, and I'm going to go back to my command here, and I'm going to add a second migration. So this is now going to change all of my string properties, string columns to a max length of 200. Now it's told me I've got some data loss. That's because I'm narrowing the column here down from max length to 200. But since we don't actually have any data, that's okay. We don't need to worry about that. So you can see here now I've got a second migration, and we've changed the columns to nvarchar 200. Okay, so traditionally with migrations, you could now do a .NET EF database update, and it would apply the migrations to the database. New for EF Core 6 is a thing called migration bundles. So for that, you do .NET EF migrations bundle. And what this is going to do is create an executable file that's specific for the platform. So I'm on Windows, so it's going to give me an exe. If I were on Mac or Linux, it would give me an appropriate executable for that platform. You can see here we've got this executable. This executable requires the .NET runtime on the machine, but not the SDK. That's the default. You can also build it as a self-contained executable, which doesn't require anything to be installed on the machine that it runs on. So this now has bundled up all of our migrations, so I can use this in my CI/CD pipelines in order to apply migrations to a database. To start with, I'm just going to run this to apply the migrations to my development database I have on machine. And if I switch to SQL Server Management Studio here and refresh the databases, you'll see that we have an orders database. It's got the tables we expect with the columns that we would expect in each of the tables. Okay, so I'm going to come back to bundles in a second, but I want to talk a little bit about SQL Server temporal tables. So support for SQL Server temporal tables is something that we added in EF Core 6. This is a feature of SQL Server that basically keeps track of every change you make to a database. So when you update a row or you delete a row in a database table, SQL Server will take a copy of the snapshot of that row before you make the change and put it into a side table called the history table, and thereby keep track of everything that you've done to that table. So basically, you get an audit history of everything you've done. So if we go to our context here, we can tell EF Core that we want all of these tables to be temporal tables by adding some configuration to on-model creating. So here I'm saying for customer, make the table temporal, likewise for product and order. So I save that, and then I'm going to go back to my PowerShell window here and create a new migration for it, just like we did before. Let's call this one 3. Okay, so now I have a third migration, and I'm going to recreate the bundle to add that migration to it. So I'm going to rerun the bundle command. I'm going to give it a force just to tell it it's okay to overwrite the existing one. And now I can run that bundle again, or the new bundle actually. So let's run that again, and you'll see that it's going to apply migrations 3 to the database that we created. And if we go back to SQL Server Management Studio and refresh the database, look at the tables, we'll see that now these tables say system versioned. That means that they're temporal tables. And if you look inside, there's a history table with all of the columns duplicated without their constraints, because this will have lots of additional rows for each primary key in it, which we'll get back to later. So now we have basically migrations has now created temporal tables for us in the database. In fact, if we go back to Visual Studio here and look at the migration, you can see it did that by doing alter tables and creating the different parts that were necessary. Okay, so I'm going to talk a little bit more about temporal tables in a minute, but first I want to go back to bundles and finish what I was talking about there. So we have a bundle that has 3 migrations in it now. We applied 2 to our development databases and then the third one. But now if I've tested that and everything is great, I can now take that bundle, and without rebuilding it or doing any or making any changes to it, I can just pass a different connection string to it. So here I've got a connection string that's pointing to my production database, and I'll apply that. And even though it only applied the third one, when I applied it to my development database, it sees that the production database needs all 3, and so it applies all 3. And this is the kind of power of migrations. It keeps track of where your database is and updates it to the correct place. And in fact, if I just run this same command again, it's going to say there's nothing to do. It's already up to date. So you can take this bundle, put it into your pipelines for deployment, have it update your production database, and that's the power of bundles. Okay, so enough on bundles, and let's go back and look a little bit more at temporal tables. So the thing about temporal tables is that it works on history. In other words, you need to have some data in the database to make it useful. And so, in order for this to show this in the demo, I've just got this make history function, and it puts a few products, a DeLorean, a flux capacitor, and a hoverboard into the database. Then it does a thread sleep to wait a little bit, changes the price, same again, change the price on the DeLorean, creates an order, and so on and so forth. So with that, we can now run a program here, and I'm just going to comment out these other 2 lines here for now, and we're going to make some history and then look up the current price of the DeLorean. So let me run that, and you should see, okay, we're making some history. We did that, and the DeLorean with this PK is currently $150,000, a bargain. Let's look at this lookup current price. So this is an important thing. Most of the time when you're using temporal tables, you just use them as a normal table. You don't really care what's happening, what the history is and everything. So you just, in this case, I'm just doing contact product single, normal thing, and just printing out thing. Nothing fancy, it's all the same. However, because we're saving all that data into that history table, when we want to, we can go back and look up the history of everything that changed. And we have new link operators in EF Core 6, one of them called temporal all, and that says, bring back me all of the history. So we're looking up for the history of the DeLorean. We're going to look at all the changes. So let me run that again. We make some history again, and we now get all of the prices of the DeLorean. It went up in price to 2.5 million and then back down and up again. And you can see these all have the same PK because these aren't different rows or different entities. This is the history of a single entity instance, the history of a single row in that table. There's other operators here. So we have temporal from 2, which takes a range of date times. And if I run that again, it does basically the same thing as before, except this time it's just going to limit the history it shows you to between those 2 times. And there you go. And then finally, we have this operator temporal as off. And this one, unlike the range ones, takes a specific point in time and says, give me what that table looked like at that specific point in time. And because all of your constraints in your database are conserved at that point, they're all valid, you can also now bring in other parts of your model. So you can say, okay, the order at that point in time, and also what did the product look at that point in time, and what did the customer look like in that point of time. And so if we now, let me make sure I uncommented this, and then we'll run this again, and we'll see that it looks up the order for when I ordered a DeLorean, and it was 2.5 million, and my wife was not happy. Now, this is just a very small part of a much bigger demo and chat that we had on the Entity Framework community stand-ups that we stream live every 2 weeks to Twitch and YouTube. This is on YouTube, so if you want to see all the details, what happens with the from to, the shadow properties, all that good stuff is in the Entity Framework community stand-up. So I encourage you to check that out. And now back to Jeremy.
Thank you so much for making history at .NET Conf, Arthur.
You're
Appreciate
welcome.
that.
Love to make history.
Absolutely. So we made some history with Azure Cosmos DB and added a bunch of new capabilities that I'd like to showcase. So I'm going to pop over to my application. I created my own blogging app, and I have 2 blogs here. One is this codes blog, and as you can see, I can come search for a thing, and I'll get a thing and possibly another thing. And then I told my friend Brady that I'd show his face on the presentation, so we got him into the talk here, and he just has a love of .NET. So I could click on these links and drill into it, but the problem is this is all mocked code. So let me take you behind the scenes and show you. I basically made an interface for blog access. Now what I like about this interface is on the client, and I'm using Blazor WASM, I can come into the client and implement that interface as a bunch of asynchronous web calls using HTTP client. So these are just calling out to a traditional controller. If we go onto the server and look at the controllers, let me just drag this out real quick. The blog controller is using Entity Framework, or actually it's using my interface to get access. And then the implementation of that access is just a fake C# class. I'm basically hard coding the blogs. So what I want to do is use a Cosmos DB database that I have real data, and this is the data here. We've got blogs with posts inside of the data, and I want to wire that up. So the first step I already took, and that is adding a reference to Entity Framework Core, and you can see that reference is right here down in the under the packages reference. So we've added that. The second thing we need to do is make that glue between the domain model and the database. So I'm going to add a new class, and I'm going to call this creatively blog context. And then to save some typing, I've got a special snippet. But you'll see that there's really not much to this. When we do the blog context, what we've got after I do my magical control period, right, to pull in the usings, is we've got a constructor that takes some options for configuration, and then we've got a DB set for the blog. This is all the configuration I need to wire this to the Cosmos DB database. Now the next thing I'm going to do is implement a quote-unquote real version of the blog access. So I'm going to call this Cosmos Blog Access. And this one will be a little more involved, but not too much. So one of the things before I implement this, if we look at the mock blog access, you can see I'm using a projection here. Basically, the blogs contain all of the posts, and we don't want that to display. We just want the blog header information. So this projection just selects the pieces that we want. Now this is using fake blogs, this is linked to objects, but we can do the same thing with our actual interface to Cosmos DB. And let me show that. So for the blog access, and again, I'm going to do a few magical control periods here to bring in my usings. I think I have one more at the top. So what I'm using is a DB context factory. That's a configuration that I'll show you in a second that gives us an instance of that context. I'm using the same link statement here to do the projection. So that will get translated to Cosmos DB for me and only pull back the fields and properties that I want. Same thing here. Now for the filtered posts, that was a much more complex query. So I'm excited to share that no matter how complicated the query is, if Cosmos DB can handle it, we can translate it for Entity Framework Core. So here I'm taking raw SQL and projecting it into that blog post. So now I have the elements in place. I just need to update one more piece here. And we're going to add some configuration to actually wire up the blog context. And my friend Christos, who's going to be on a little bit later, is always harping on me about security, that even in demos, I should be aware of security. So I wanted to make sure I got my keys from some completely secure location. So we've taken care of that, grabbed our keys, and then I'm just going to use Cosmos as the provider. And the very last thing I'm going to do is, instead of our mock blog access, I'm going to switch this to the Cosmos blog access. We're going to hit F5, let that spin up. And you know this trick, right? With the mouse clockwise, always speeds up the build, brings us to the screen, and we can even help Cosmos out a little bit and wind it up right here. And now I've got these two blogs that are live from my Cosmos database. In fact, I remember there was a mentoring ring discussion that I can search for. Here's an engineer mentoring ring. And on my personal blog, I happen to be a huge fan of Cosmos. So if I type in the search term Cosmos, we can pull out all of the different blog posts that I've presented on Cosmos. So that is what I wanted to show you there. Now, Arthur mentioned that we have some community stand-ups that we host pretty much every other week, and we have different guests on, and we talk about all things data related. You can access those with the link on your screen. You can also see what's new with EF Core. And at that, I'm going to answer some questions, I believe, and welcome my friends Jamie and Scott back.
Hello.
Hello.
Hey. Great
Thank
job.
you for putting in the work with us today.
My pleasure.
Let's go to the big board here.
Arthur's the
have
one who made the
questions.
history, though, so.
What's that?
I said Arthur's the one who made the history.
Okay,
Thanks, Arthur.
appreciate that. All right, let's see here. Metadad has a question. Do we gain the same 92% performance with other providers like Postgres provider?
So it was actually the Postgres provider that was used. We're using the industry standard Fortunes middleware benchmark, and that uses the Postgres driver. So that's exactly where that performance came from.
Wow, okay. That's a way to make the point very clearly.
Yes.
So cross-platform and running on Postgres, not benchmarked on SQL Server for that particular benchmark.
Correct.
Cool, congratulations. That's a retort I didn't expect. That's really great. What's this one here? Temporal tables?
Temporal.
Temporal tables sound awesome. What is the cost? Memory, disk space, CPU. There's always a cost.
Wish I had the memory and disk space off the top of my head, but it is a feature of SQL Server. So regardless of if you implement it in EF Core, it's taking the same hit. And because it does have extra writes, the writes do have overhead, but SQL Server is really good, right, at managing this at scale. So it, in most cases, should not have a major impact on what people are doing.
Okay, that's cool. That's cool. What else we got here, Jamie?
Yeah, we got a few more. Where's that compliment?
Oh,
One.
yeah, an appreciation one there. There's an appreciation one there. Oh, here we go. What do we
I
got?
think we got a good question, though. Is the SQL project file still supported in VS22 without using EF Core migrations? Are complex migration scripts also supported in EF Core migrations? And greetings from Germany.
That is a lot bundled in there. Do we still have Arthur? Arthur, do you want to take that one?
I am here, yes. Yes, so yes, we support a database first workflow, so you don't have to use migrations. There's actually some really good blog posts by one of our great community guys, Eric EJ, that shows how to use project files and DAC files with SQL Server, so you can still manage all of that stuff. As far as the complexity of the migrations, we support some pretty complex stuff, but anything you don't need, you can just put your own raw SQL into your migrations and pretty much cover anything that you could possibly do in SQL that way.
All right. Okay. That covers it all. Multiple questions, multiple answers.
This one?
Yeah, it looks like a compliment here. Automatically recording usable history. People appreciate the temporal tables and new easy link methods.
Nice.
Patrick likes that. And what is Jacob asking here?
Jacob asks, EXE?
To build an XE, what? I'm trying to, these things fit into tweets rather, it's hard to tell.
Yeah, and all of the
this
acronyms.
is more of, is it better than a DAC pack?
So again, DAC packs are still supported. They have a kind of different flow, but if you want to use a DAC pack, that works great. I believe they're still SQL Server specific. EF Core migrations work SQLite, MySQL, Postgres, all of the databases, and so it has that. Basically, whatever works best for your particular application and your particular development flow that you're using, you can use anything. Okay.
So use what makes you happy is the answer, what I'm hearing right there.
Yes.
All right. It looks like somebody took a screenshot. They were so excited about the 92% improvement in requests per second just by upgrading. And again, we heard on Postgres is what you did that on.
That's what we did that on. But it includes not just EF Core enhancements to the query pipeline, which all of the providers take advantage of, but it also includes the runtime improvements. So just going from .NET 5 to .NET 6, we saw massive improvements in several areas. And so that is something we take advantage of, right, with the new product.
That's actually a great point, because Stephen Tobe had that really long blog post a couple of weeks ago on .NET 6 performance, and that kind of reminds us all that when performance improvements happen at that low level, then everyone who sits on top of it gets to ride that wave, whether it be span of T or low-level things in the garbage collector or the jitter, everybody wins. And in this case, we don't know what percentage of those you got for free, but a lot of cool benefits that you could sit on top of and then squeeze even more performance out of that.
Absolutely.
So we actually have a community stand-up from a few months ago where Shai, who's our main Postgres developer and also on the EF Core team, does a lot of the perf work. And he went into all the detail of the different components of that, which bits came from the frameworks getting faster, which bits from the Postgres low-level driver getting faster, which bits from EF Core getting faster, and which bits from just optimizing the way we use the benchmarks, for example. So if you want to learn all that detail, it's right there on YouTube to go find.
So that was a community stand-up that we did how long ago?
That's correct, yes.
All right.
It was during the EF Core 6 timeframe, so I'm thinking maybe 2 or 3 months ago.
Okay.
Yep.
Cool.
And that EF stand-ups link has the whole list and the playlist, and there's also a blog post from one of the releases that goes into details too.
Yeah, that's a good reminder that folks can go to dotnet/live, right? We've got the TV. So you go to the .NET website and you just click in the upper right-hand corner there, and there's actually a little chiclet that says Live TV. And in fact, when that is pulsing red, there's something live happening. And whether you want to talk to the EF team directly and hang out with them, spend time with them, or any of the other teams that you've been seeing today and throughout the conference. Pretty cool. Thank you so much for your time.
Thank you.
Jeremy.
Appreciate it.
Thank you, Arthur.